you've probably heard that the top speed of some type of aircraft is Mach 2. Or maybe you watch some type of, I don't know, science fiction movie or some type of fighter movie where they say, hey, we are going to travel at Mach, at Mach 1.8. And you had a sense, because they're using it in the same context that you would use a speed, that this is some type of speed, that these numbers represent some type of speed. And if you assume that, you are right. And the speeds they represent are actually a multiple, or depending on how you want to view it, multiple or fractions of the speed of sound in that medium. So if someone tells you that the Mach number is 2, what that tells you is that they are traveling 2 times the speed of sound in that medium for those conditions. And I make those last two, I guess, qualifiers on it because the speed of sound is not always the same. It has a different speed depending on whether it's traveling in air or water, or even depending on what makes up the air. And even if it is only traveling in a certain type of air with a certain, with a certain makeup of mix of gases, it'll also change depending on the temperature. So if you're at sea level at roughly about 20 degrees Celsius, the speed of sound is 300. So sea level, let me do a different color, maybe blue for sea level. So if you are at sea level, the speed of sound is about 340 meters per second. This is at 20 degrees Celsius, so it is a nice, comfortable temperature at sea level, which is roughly about 760 miles per hour. Now, if the temperature were to drop, so if temperature goes down, if the temperature goes down, so does the speed of sound. Sound speed also goes down. And likewise, if the temperature goes up, the speed of sound goes up. So when someone tells you that something is traveling at Mach 2, they're saying it's traveling at 2 times the speed of sound for that medium. Usually they're talking about something traveling through air, and for the speed of sound at the temperature that they're going through. So if they're traveling, if they're at some super high altitude, and normally to travel at these types of speeds, you have to be at a fairly high altitude where the air is less dense. You're also traveling in an environment where the temperature is significantly lower than than 20 degrees Celsius. So the speed of sound. So you might say, hey, does that mean if someone's traveling at Mach 2, does that mean that they're definitely traveling at 680 meters per second or at 1520 miles per hour? And of course, whenever someone gives you an airspeed, it's relative to the air. And the answer is no. They're probably going to be traveling a little bit slower than that because at the altitude that they're traveling, the speed of sound is slower. Now, there are ground speed records where they are traveling in kind of the Mach range, where their velocities are high enough to say it in terms of Mach. And for those types of situations, they are traveling at multiples of 760 miles per hour, 340 meters per second. Now you're probably saying, "Hey, who is this person right here that I've cut and pasted from Wikipedia?" And this is Ernst Mach, and this is what the Mach number. This is who the Mach number is named after. Ernst Mach, and he was this Austrian physicist and philosopher. And he did a ton of research on shock waves and sound waves and whatnot. So the Mach number is named after him.